Graphing rational functions without calculus. Part 1. What you should know before you begin. Well, you should know that a rational function is a polynomial divided by a polynomial. That's the first thing you should know. And you should be able to sketch polynomial functions. If not, go look at the YouTube movies where I do sketch some polynomial functions. And the third thing is that you should be able to solve rational equations. So you should be able to work with these rational equations in solving for x. Okay, we move along here. Here's our first example. And what we're going to do, of course, as usual, we're going to find the y-intercept. Very important thing to find, where it hits this y-axis. And of course we set x to 0 to do that. And when we do that, we end up with y equaling 4/5. So 0 and comma 4/5 is the y-intercept. Very easy to find, just like within polynomials. In fact, a lot of the steps will be the same in rational functions as they were in polynomials. Step 2, the x-intercept. Set y to 0, so we set y to equal to 0, and solve for x. Now, to solve this rational equation, really whatever makes the top 0 will make the whole expression 0. So I just have to really set the top to 0 to find out what x's will do that, and I get x equals 4/3. So 4/3 and 0 is my only x-intercept. The next step is the lead term test. And the lead term test is very similar. In fact, it's the same as the lead term test for polynomials, except that we look at the top and the bottom. A lead term test can indicate a horizontal asymptote. I'm going to abbreviate that with HA, horizontal asymptote. Caution, we do not necessarily have a horizontal asymptote. You don't have to have one just because you have a rational function. And the graph, if we do have one, the graph may cross the horizontal asymptote near 0. Eventually the graph will get arbitrarily close to this horizontal asymptote. So I look at the function, I take the lead term on top and the lead term on the bottom, the highest power, top and bottom, and I get negative 3x over x, and that's what y is approximately as x gets big, either in the positive or negative sense. Of course, we can reduce this to negative 3. So we say that we have a horizontal asymptote at y equals negative 3. And the interesting thing is this function, which was so complicated, a rational function, just turns into the horizontal function y equals negative 3 as x gets very, very big. Symmetry, we don't have any symmetry. You can check that out. Plug negative x into the original equation, and you don't either end up with function of x or negative function of x. So you have no symmetry. Vertical asymptotes, now that's completely new. Okay. Vertical asymptotes, or VA, given the rational function is reduced, that is, you can't factor it and cancel out any factors, any x that makes the denominator 0 is a vertical asymptote. So this is completely reduced, obviously. Here we set the denominator to 0. We find out what makes it 0, and we find the line x equals negative 5 as our vertical asymptote. Okay. It's what makes the function undefined. Let's keep going here. Now we want to place our intercepts and asymptotes on the axis here. Let's move it a little bit more. All right. Oh, I've got the intercepts here. Here they are. I've got them all here. That's good. Let me get this more centered. Okay, here's our y-intercept, and then over here we have our x-intercept, and then we have our horizontal asymptote here and our vertical asymptote here. And we kind of get an idea of how this thing is going to graph. Now this x-intercept came from an odd factor. It came from a factor that to the first power. So you're going to go through that x-intercept. So we know that this function is going to eventually just be this line, this horizontal line. So I can cruise in like this. I have to go through this intercept. I go through it. I don't know how high I'm going to go, or low, or anything. But I know this. I can't go through this vertical asymptote. And I'm thinking, well, can I go down this way, or do I go up this way? Well, I can't. I don't have any x-intercepts here either, so the only way I can go is up like this. So it comes right along here, it goes through here, it goes through the y-intercept, then has to go to, has to go through infinity this way. From the other side, we know we're going to eventually be this line, -3, so I'm cruising along like this. And I can't crash into that. I can't go through that vertical asymptote. So I either have to go up or I have to go down. Which is it? Well, I can't go up because there's no intercept, so I have to go down. So that pretty much tells us the story. And here's the function graphed. There it is. And just sort of the way I described it earlier. And what we'd really want to do before we can tell what really happens, we'd have to, or all the details at least, we'd have to get out the old graphing calculator and do it, right? But that's a pretty rough idea of how what this thing's going to look like. Now you should get out your graphing calculator and stop the movie and use this window and type in this function for y1 and graph it yourself and see how close that we came here on this particular function.